Okay, so here's why your Obsidian knowledge base sucks, how to fix it, and then a better system to use called the Retrieval Augmented Generation, or RAG, which is multiple times faster than Obsidian and much higher quality in the system that I've officially switched to. You've probably seen Obsidian on YouTube. You have the very cool little Obsidian knowledge graphs here, but do they actually do anything? I feel like nobody seems to want to ask that question. So here's some of the thumbnails you may have seen. But what Obsidian actually is a note-taking platform. So you'll have been seeing this. This is a little mock-up that I put together because I don't use these anymore. But all of these lines are connections to other notes. So if you click on one of them, this is what it looks like inside of Obsidian. Just notes, and then you can link different notes inside of each one of the notes, which is exactly what creates this graph. So why is AI good at this? Well, the reasoning is because it's supposed to help add extra context. So if you want to learn about Pinecone or vector databases, or you're asking AI about it, it can then find the links to similarity measures, log, overview, index, whatever. And really, well, you start from an index, I suppose, in at least everything, but it'll route through the index and then find which one of these topics you're talking about, go to that topic, and then it'll expand upon it. So like you've seen in this. But the problem is AI will not by itself simply go into Obsidian and find information. It's not a brain in the slightest. So what a lot of people do is they make this cool thing and then they tell Claude every single time, hey, check your brain. It's not really a brain if you have to tell it to check it. You can tell it to check the internet and it would find you the same answer. So how do we actually engineer it so that that works? Well, you have two options. You have either the CLAUDE.md folder or a hook. We're going to lean towards hooks here because they're way better than CLAUDE.md. But if you don't know what either is, I'll explain it to you now. So CLAUDE.md is essentially like a behavioral recommendation for Claude. It reads that file every time before it responds to you. But the difference is it's not forcing Claude to do anything. So if you put in your CLAUDE.md, read the Obsidian index, then it will go in and it will read the Obsidian index. But then it'll stop there because your wishes have been completed, and then it will go from there. A general rule of thumb that you can take away with AI is it will do the minimum amount to just satisfy what you want it to do and no more than that. Which is the exact problem with Obsidian knowledge bases, is they rely on AI in themselves. So you're assuming that Claude is actually going to do a good job of collecting all of the facts before responding to you. And to be honest, it's not. Which is where hooks come in. And so hooks are basically injected. It's a little bit more complicated thing. I'll put a link in the description if you want to go look at the actual docs on Claude Code. A little bit more in depth, well, a lot more in depth than what I'm telling you here, but a little more complicated than you're probably used to. But all you really need to know is this singular hook, which is called UserPromptSubmit, which basically runs a program as soon as you hit enter when you send a message to Claude. And that program runs before Claude actually registers that you sent a message. And so the sequence is you type out something, what did I say in yesterday's meeting, and you hit enter. It sends off to Claude. But before it actually gets to Anthropic servers, before Claude actually answers you, before it even registers what you've said, this hook intercepts your prompt and will change it. It will perform some sort of action before Claude even gets the message to respond. And so what you could do is in this UserPromptSubmit hook, which is, again, when you hit the enter button or send it, is tell it to, hey, read the index file. Okay, so in Obsidian knowledge bases, you're probably familiar, you have this index file. Well, it routes to all of the knowledge base. You can tell it to read it. So then the result of that is your message is sent, but then it holds all the extra information that it already read. It's basically just injecting something into Claude's context before it even reads your message. And this is pretty valuable because then you don't have to rely on Claude choosing to go do something. You can force it to do so because it's no longer Claude that's choosing to do it. It's a program, and programs are like binary. It's yes or no. They either do it or they don't do it. They follow the rules exactly. There's no behavioral, like AI type of decision-making skills, right? But then the problem remains is with Obsidian, then it has to go from that index and find exactly what you're talking about to get more information. And then AI is involved again. And there's never a world where you will submit a prompt and then it will automatically inject exactly the part of the Obsidian knowledge base that you're looking for. That's just not how it works. How it works instead is AI will then go in that index and search a bunch of different files, right here, right here, right here, right here, until it finds the one that actually has the information. But the problem is each one of those file reads took up a bunch of tokens, so it's going to be extremely expensive, right? But the answer was only 2,000 tokens, but it had to go through 8,400 before it found you the single answer, which is, again, the problem of using AI to navigate a knowledge base in order to get you an answer. The second issue nobody's talking about is that AI, you have to be the librarian for it. So assuming you start a new part of your business or you start doing something new, you have to go in and manually add this to your Obsidian knowledge base, or you can have an intake go ahead and do it for you. But the thing is if there isn't a folder or a file in that Obsidian knowledge base that already contains something, then it's going to have to create a new folder or a new file for that topic. But then you're relying on AI to create a folder structure for you for a knowledge base. And when you start doing that, then it starts designing it like AI would think, not how a human would think. And you'll never be able to navigate this thing to find what you actually need. It'll become a web of AI stuff that doesn't make any sense. That's the problem. And so over time, the quality degrades, and then eventually you have to go reorganize it yourself. Is a huge pain. And we want to be hands off. So what exactly is like the solution? What is the better option to this? And that is RAG, which stands for Retrieval Augmented Generation. So we'll break each of those down. Retrieval is basically meaning it's going to retrieve it from somewhere, it's grabbing it. Augmented means it's stapled upon something, it's added to, it's appended to. Augmented is changed or upgraded, I suppose. And generation is just AI, it generates an answer. Now, retrieval is basically going to grab the answer and then it staples it onto the prompt, which you send. That's what RAG is. And each step that we take in order to actually use this is you'll have some sort of data ingestion sequence. So for me, I have every 24 hours when I'm asleep, it will set off a timer on my laptop, which I keep on at all times. And it will go through everything in the last 24 hours that's happened in any YouTube transcripts, whether it's my channel or other channels that I want to get knowledge from. iMessages, which this is more for fun. I don't think anybody's going to do this, but if you have a Mac, your Mac actually does store your iMessages locally, and so AI can access them if you want it to. But the more valuable ones are going to be Slack messages and past Claude sessions. Slack messages, if you have a business, it'll keep up to date on conversations, meetings, anything that was discussed. Past Claude sessions is by far my favorite one. And the reasoning is because it will go through the entire transcript of your sessions from the previous day, and it will basically throw out 99.999% of stuff. But it will keep specifically things like problem, solution, date. So what was the problem? Okay, it misgenerated an image. I don't know. Solution, prompt this, and it had a good result. Therefore, next time the user prompts something like this, it's probably valuable to know this beforehand so they don't have to say it again, and then it has the timestamp, which is the important part. And so these are called chunks. So you'll take all of these tons and tons of files and information the last 24 hours, feed them into an ingestion agent. This will all happen automatically without you needing to be there. And this agent will basically take away that 0.001% of the information that's actually valuable, split it into text, source, and timestamp. Text is actually what it says. So, oh, hey, I have a meeting tomorrow at 11:30 a.m. with Bob. That's the information. Source, Slack, timestamp is exactly when it was either intook or when the thing actually happened. So if the Slack message happened yesterday at 12:02 p.m., timestamp. Although I'm pretty sure about 90% of the time, the timestamp is just the date. Probably all the time, actually. And the reasoning is because it's so much easier to just assign a date, because typically if it's valuable information, such as a meeting at 7:49 a.m. tomorrow, the time that you sent that message doesn't matter. It's the meeting that matters, which is going to go in the text section. But when you actually grabbed it, which is the date, is what actually matters. And we'll get into that in a minute. But once you have all these chunks and valuable information, we actually have to put them somewhere, which is where you get into a vector database. And so say this is a terrible example, and I don't know why this is here, but we'll say the price of our websites is $500 for everyone, right? It will then take that chunk of information, which maybe it found in Slack, and it'll feed it into an embeddings model. You have two options here. You either use the one that's local on your computer, completely free, or you use OpenAI's text embedding 3 small, which I would recommend. The quality is going to be a lot higher, and it's very inexpensive. If you have like $5 or whatever the minimum amount is, I would go to OpenAI, set up an API key, and then add $5 to it. And I've never run out before in my life. So it probably will not run out unless you're intaking absurd amounts of data, then you might. But it's worth the money, in my opinion, because you're probably never going to run out of it and the quality is going to shoot upwards. But if you're on a budget, I completely understand. Use the free model on your computer, which I'll walk you through in the future. But then it will take your information, it'll put it in embeddings model, and then it'll basically create coordinates. These are semantic coordinates for a vector database, which I know is very kind of technical, but basically what it means is it breaks down the meaning. We hold at $497, or our websites cost $500. Okay, websites, $500. Our, who are our? It takes the meaning out of the sentence. Who is our? Our is probably our business. Okay, what's our business? $497 for websites. Okay. And it will basically distill it into a coordinate plane. This is the most important part of the entire video. So this is a vector database, and this is basically where all of the information is going to get pulled from and how AI is going to stay accurate with the information that it gives you and actually build a brain. So this, in a way, is the brain. So this is your query, this little star right here. So say if you asked how much is our websites, or what is the price for our websites? It will literally put that in the database. It won't store it, but it'll basically query it. Hey, here's the information right here. And it will pull the most relevant dots, which would be called chunks, from the database, and then staple it onto your message before Claude even gets it. And so you'll notice on here that we're talking a question about pricing revenue. So how much is the website? Well, you have travel as every topic here, content ideas, workouts, cooking. And you'll notice that travel is closer to content ideas than pricing revenue is. Likely because on a semantic level, there's more to do with travel and content ideas than there is with content ideas and pricing revenue. And cooking and workouts are much closer related because meal plans, nutrition, and workout. They're very closely related, so they're going to be closer together on this. Now, this is not a 3D thing. There's a lot more dimensions to it. This is just for us to be able to comprehend it. But this is 3 numbers, and it just keeps going. There's tons and tons and tons of numbers there, which you don't need to know. None of this matters to you. What you need to know is you're asking a question. Here's where it lies on the graph. It'll just grab the closest information that's relevant to it and then feed it back. So, for example, if I ask how much is the website, it'll grab, oh, okay, on this date, this is what was said, and this is where you got it from. So on June 19th in Slack, there was a message that said the price of our websites is $500. Oh, but over here, there's another one that says our websites are $800. Oh, our websites are $700. So it may pull back multiple pieces of information that are conflicting, but then we filter by time and date. And so if you said in Slack that our websites are $500 and that was the most recent website that was timestamped, that's the information that's going to get pulled. And it'll only pull the relevant information. And so this gets rid of the whole Obsidian problem, having to go find the information, is it just automatically pulls it. This is a program. AI is not going in and searching for this. It is grabbing it automatically, because if you think about a graph, you can see all the dots that are closest to it. It'll just go grab the dots. There's no AI necessary to make that decision. The 8 closest dots are the 8 closest dots. You can grab them. And that's kind of where you get into a whole different thing, which kind of, it matters, but not for you. How many dots do you grab? How much information do you actually want to get from this? Well, I do 8, completely arbitrary number, but I shoot for between 5 and 10 pieces of information. If you go below 3 to 5, you might completely miss it because it might grab these 3 dots over here, but you're looking for this one. So you need more information to actually get a little bit of a range here, which will give it even more context. But if you go above like 10, you're going to get all of this. But the problem is if you go even higher, then maybe it'll grab this one over here. And then you're getting information that you no longer need and it's not valuable anymore. So I would shoot between 5 and 10. I have it preset to 8. You never have to worry about this. It's good to know why though. And then we use a hook for this, which this is the exact same diagram that I was at earlier. But basically now, instead of using, hey, look at the knowledge base index, we're going to say, hey, run this program. There's no looking around. So when I text, what did I say in meeting yesterday? And I send it. When I send that message, before Claude even clocks it or gets it, it'll automatically say, okay, user submitted a prompt. We're going to run this program called RAG recall. And it's going to feed back the 8 closest chunks of information that are most relevant to his message. This is my message. So like, what time do I have a call tomorrow? The 8 most relevant chunks, and then it will staple it on or append it to your message before Claude even gets it. It's injected. And so this is like literally a perfect example is what did I say in yesterday's meeting is what you sent, but Claude gets this whole block up here that has the iMessage and the date and the chunk that says we hold at, this is a terrible example, but 2 p.m. is the meeting. And it'll say, like, this is just an example. There will be more in-depth information here, but basically it'll say the source. Okay, in iMessage, yesterday, it said that we have a meeting tomorrow at 2 p.m. Well, yesterday is the most recent one of the 8 that it got. So that's the one that we're going to use. and then that's what it's going to answer. And so Claude is going to have answers far more accurate because it doesn't have to go search for it. It instantly replies with it, because to Claude, it actually looks like you're asking the question and sending the answer in the same message. And then you're removing the agent's opinion and all of that. And then this is the same thing if you want to go follow the link to read more about the hooks. Super useful. I use them a ton now. But I know I made like big claims about how this is so much better than Obsidian. So I went and actually kind of tested it in a way. I didn't test it against Obsidian because I don't have anything Obsidian related on my computer anymore, and I wasn't going to spend the tokens to make a huge Obsidian knowledge base that I'm never going to use in my life. So instead, I just gave an agent file access to my computer to search anything, which is pretty much the same as Obsidian, maybe a little bit worse because there's not the index to actually route it. However, the output will be the same, and I'll explain that why in a second. But I basically took 15 questions of varying difficulty, varying specificity. So some of them were gimmies like, what is 3 plus 7? Other ones were like, hey, what was my financial data yesterday in this bank account, like under this company, like something completely random that Claude would never know unless I had access to information. And I ran it against each other, 2 agents. And the RAG returned correct answers to the 15 questions, all of them, in 2 minutes and 23 seconds. The agent that had access to my files did return the answers, although they were not all correct, to a point at least, in 12 minutes and 27 seconds. So it was 5.2 times faster to use RAG instead of just having the agent go through your computer and find the information. Token spend is going to be what you guys want to know about. And so it was 3.5 times cheaper. Great. So anytime you ask questions now and it needs to actually pull information, it's going to be 3.5 times cheaper instead of searching your files. The only reason in the first place that the raw files is so large, and the same reason why the Obsidian token usage would be so large, which is kind of my primary selling point, I guess, for RAG over Obsidian, is because in RAG, the agent doesn't have to read a bunch of files. It just gets the information in your message. Now, your message is going to be bulkier, but it's going to get the more accurate information. If it has to go through Obsidian, or in this case, read your raw files, it has to actually grep or like read the files. It has to read them. And all of those contents of those files get loaded into the context, which uses more tokens in the future. And so in RAG, it's not reading anything. It might read a few things, which I guess is these 16 tool uses down here. But it's reading nowhere near as much, or 6 times less things than if you use raw files or Obsidian. And so this is where this big token usage comes from, is because it's going and reading a bunch of files. RAG doesn't read the files, at least not all of them. And then tool calls is kind of exactly what I was just saying, is you can kind of gauge how many files does this thing have to go through is usually what the tool calls are. Sometimes it's other things, sometimes it's not, but most of the time the tool calls are Claude reading files. And it only read 16 versus 95, so 6 times less, which this raw files thing would likely be maybe 60 or 70 with Obsidian because we had the index routing. Tokens would probably be maybe 150, 200,000. It would not be nearly 68,000 because, like the example we had all the way up here, it has to actually go through multiple before it actually finds what it's looking for. And it might not even be up to date. It might be completely outdated. And something interesting that I could cover, it's probably not really useful to you at all, but the raw files one actually found an API key on my computer to go pull my finances live. And so it actually got more up-to-date information than the RAG agent, because the RAG pulls every 24 hours. And so maybe it was 12 hours old versus the raw files agent pulled it live and it was immediate. So maybe it was like $10 of a difference. So it was similar enough, but the RAG was actually the outdated one here. And so the only solution to this is to up the speed at which your RAG pulls. So the cron job, or the timer. So I have it once every 24 hours. You could up it to every 30 minutes, every hour. But the problem is then you're just going to be spending all the more tokens, because it's going to go and ingest all this new files and use all this context stuff that it doesn't need to. Because realistically, yes, maybe 2 or 3 out of the 15 questions, the raw files is actually more up to date because maybe I edited a file in the last 30 minutes. However, it's using this many more tokens, and that's just not worth it to me. And nothing meaningful changes in 24 hours to warrant this system over RAG. And with that said, there's just the differences I literally just explained. And now the whole build from end to end is you'll paste a block, which I'm going to give you, and then it'll set up a daily cron. So a cron job is just a timer essentially that runs on your computer. And then all you have to do manually is add environment variable keys for the data pulling. So up here, The only thing that you have to do with this, because I'm going to give you the rest right now, is set up the ability for Claude to pull this information, which is by setting up the environment variables, which again, it can walk you through doing. So once you set these up, then it will automatically pull for you. It will automatically store the information inside of this very sexy looking vector database. And then it will automatically set up the hook for you so that every time you send a message, it'll pull the information from here, inject into the message, and then Claude will answer it, which is going to give you these results. Now, this is going to sound a little bit salesy. I hope it doesn't, but I set up a little, oh, I lost it. There it is. I set up a zip folder for you guys, which when unzipped becomes this Claude second brain file. And this is all the contents of it. What I want you to do is inside of my school community, which forgive me, I'll explain in a second. You can navigate to, once you join, then you can go over to the classroom tab and go to resources and it'll be here. And you can just click on this and download it. The reason behind this is because YouTube, it cannot store zip files. YouTube does not allow me to store files, so I need to store it somewhere. And so naturally, it would be great if you could join my school community, but it also allows me to store something somewhere. And so you can go in here, you can grab it. Once you have that, open Claude, whether you're using Terminal, you can use VS Code, the Claude extension inside of it, Cursor, you can use the Claude desktop app. That doesn't matter at all. What matters is that you're using Claude Code. You're not using Claude Cowork. You're not using Claude like the web app. You need to be using Claude Code for this. And then all I want you to do is grab the file, double click to unzip it, take it and drag it into chat and drop it. This is what you'll see. So it'll show the file path, or it'll actually attach the file depending on if you're in like the Claude desktop app. And then just type ingest this folder. And that's all you have to do. Everything else I've already done for you. It sets up the exact system that I talked about in this video. It will ask you a series of questions. So it'll say like, hey, what do you want to connect? Do you want to connect Gmail? Do you want to connect your iMessages? Do you want to connect Slack? I already set it so it automatically goes through your session transcripts, because I think that's the most valuable part of it, is it basically self-improves each day. And I've had more than one occurrence, I think today, where the agent was like, hey, we had this issue yesterday, but I have the solution from yesterday's agents in their past sessions, so we'll do it this first try. And so it actually pulls the previous mistakes and appends them so it doesn't happen again in the future. So only thing you'll have to do is stay tuned for this, allow it to run through, answer the questions, and then it may be a little bit tedious to go ahead and actually link the accounts. But once you do, wow, I'm terrible at typing. You can go into here and just log into the API platform, make an API key, and then you can set up the embeddings. Once you set up the embeddings, or you can use a local one, again, this thing will walk you through all of it, but it'll all be set up for you. This whole thing in the video, I just wanted you to understand how it works so that you can see exactly why it's a better option than Obsidian. And so the nicest part is you can just prompt the agent once it's you figured everything out, and just say like, if you do already have an Obsidian knowledge base, just say, hey, go in my Obsidian knowledge base, grab all the wiki and the information and ingest it into this RAG. And that's what I did. So when I migrated from Obsidian over to RAG, I literally took all of the information from my Obsidian and broke it up into these chunks, put it into the vector database, and then deleted all the files, because they do get stored in the vector database. And it's just a SQL on your computer. And that is the end of the video. I hope that you learned something, and I'm pretty sure that this is going to work really well for you. And yeah, I wish you the best of luck.